Alright, in this video we're going to be doing more with division of rational expressions. So we previously talked about division. We had two properties, really just one. If you have the nth root of a over b, that's equal to the nth root of a over the nth root of b. And if you have the square root of a over b, that's the square root of a divided by the square root of b. So honestly, we can go either direction with this property, but these are equal. Alright, so let's go ahead and get started. So first of all, it says here, rationalize the denominator. So what are they talking about? Well, the denominator, so basically I'm going to just do this. What we're saying is we don't want no radicals in the denominator. So that's what we're saying. We say rationalize the denominator. So in other words, we need to get this radical out of the denominator. Now in the past, I think the number one reason was because dividing by an irrational number was not very easy. And so we didn't want our denominator to be irrational. I think these days it's more because we just want all our answers to look the same, because we might have the same answer, but they look differently. And so this is how we get our answers to all look the same. So if we have a radical in the denominator, we got to get rid of it. So there's a little trick that we can use, and we've done this kind of thing before, like when we add fractions. We multiply by some number that's equal to 1 to accomplish what we want to accomplish. Now we know that to get rid of the square root of 3, if we actually multiply by the square root of 3, that'll give us 3. And so we just got rid of the radical in the denominator. And it comes down to the fact that a square root times the square root of the same number will just give us that number. However, to make it legal, I got to also multiply the numerator by the square root of 3. So what I'm really doing is multiplying by a fraction that's equal in value to 1. And so the value of the original fraction doesn't change. So this will be 4 square roots of 3. All right, so now we have rationalized the denominator. Now on number 2, it's not as obvious that we have this problem, but remember this is equal to the square root of 5 over the square root of 13. So now we do have a radical in the denominator, so we'll have to multiply by the square root of 13. So when we multiply in the denominator, we will get 13. And in the numerator, 5 times 13 is 65. We get the square root of 65. Now we got to be careful when we do this. We may end up getting a factor inside our radical that's a perfect square. Fortunately, there's no perfect square factors of 65, so we are simplified here. Now, on number 3, we could sometimes students will multiply by 8 square roots of 2, but it's really just the square root of the 2 that's the problem. And so I just want to multiply by the square root of 2. And so we'll do the same thing to the numerator. So we have 3 times the square root of 5 times the square root of 2 in the numerator. Now remember, the radicals can be multiplied together, but that 3 is just going to have to be out front. So we get 3 square roots of 10. And then here, remember, square root of 2 times square root of 2 is 2. And then that 2 is multiplied by 8. And so we're going to get 16. So 8 times square root of 2 times square root of 2 is 8 times 2. And that's how we're getting the 16. All right, let's hold on just a second. 2. Okay, no, we're all good. I'm just going to square my answers in. All right, same thing. You might try number 3 and maybe even try number 4 and then watch the video. I'll warn you on number 4, it's different with the cube root. It's not true that a cube root times a cube root gets rid of the radical. So you have to think about that one. All right, let's go ahead and look at this. So this is the square root of 3n over the square root of 25, which is just the square root of 3n over 5. And so we don't have any issues with that one because square root of 25 is 5. We have no radical in the denominator, so we're good. Now on number 4, this is the cube root of 16 over the cube root of 9. Now, we're going to multiply by some fraction that's equal to 1. It's going to have to be a cube root. Remember, we can only multiply the numbers inside if they're both cube roots. However, we're going to get a cube root. We need to have a perfect cube in here. So remember what your perfect cubes are. You have 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64. So these are the kinds of numbers we need in order to get rid of the radical. Well, certainly 9 times 3 will give us 27. And so now we're going to be able to get rid of the radical in the denominator. And so we'll have to do the same thing to the numerator. And so in the numerator, we're going to get the cube root of 48. And so this is the cube root of 48 over 3. Now I want you to look at that. There's another issue we have here. If you look at 48, this radical is not simplified because one of these is a perfect cube factor of 48. And in fact, it's 8. We could write this as the cube root of 8 times the cube root of 6 over 3. But remember, the cube root of 8, that's 2. And so we get 2 times the cube root of 16 over 3. All right, so that one is a little bit tough because first of all, the way we work with cube roots is a little different because we need to get a perfect cube here in order to get rid of the cube root radical. And then the other problem we had was this was not simplified in the numerator. We had to do a little bit of work to get it simplified. All right, number 5. Expressions such as 3 plus the square root of 7 and 3 minus the square root of 7 are called, hopefully you remember the name, they're conjugates. So now we're going to do some additional problems where we rationalize the denominator, but we've got a problem. So on the first one here, I'm going to write kind of light, and then I'm going to erase. So let's say you multiplied by the square root of 3 over the square root of 3 to get rid of the radical in the denominator. The problem is when you distribute the square root of 3 times these two terms, because it is a single term times a binomial, you'll need to put parentheses around this and distribute. 8 times the square root of 3, that's a radical term. Square root of 3 times square root of 3, yeah, you'll get 3 there. But you're going to be stuck with that 8 square roots of 3 in the denominator. And so this won't work. Now, when we were in the last section, we learned that when we multiplied conjugates like this, we ended up getting rid of the radical just because of the fact that they're conjugates. Basically, the inner and outer products are going to add up to 0. And so basically, oops, hold on just a second. The conjugate, first of all, here is 8 minus the square root of 3, and that's what we want to multiply the denominator by. Now, if we do that in the denominator, we have to do it in the numerator to make it legal. So again, we're basically multiplying by 1, or something that's equal to 1. So in the numerator, we'll have 5 times 8 minus the square root of 3. And in the denominator, we have 8 plus the square root of 3 times 8 minus the square root of 3. So here, when we distribute, we get 40 minus 5 square roots of 3. Now in the denominator, we really only have to multiply the 8s, which is 64, and then the minus square root of 3 times square root of 3, so that's minus 3, and we get 40 minus 5 square roots of 3 over 61. Now again, if you wanted to, you could do this product here, 8 square roots of 3, and here you'll have minus 8 square roots of 3, but again, those are going to add up to 0. That's what makes this work. We got rid of the radical in the denominator. So go ahead and try number 7. All right, let's see how you did. So we're going to multiply by the conjugate, which is 5 plus the square root of 10, and the same thing in the numerator. So it's 2 times 5 plus the square root of 10 over 5 minus the square root of 10 times 5 plus the square root of 10. So here we'll distribute. We get 10 minus 2 square roots of 10. And down here it'll be 5 times 5, which is 25. And a negative square root of 10 times a positive square root of 10, that's just going to be minus 10. We're going to get 10 minus 2 square roots of 10 over 15. All right. Now you might be tempted to maybe cancel here, but you can't because this is a term and we know we can't cancel a term. All right, let's move on to the next page. So you could certainly try these 4 problems. They progressively get more challenging, of course, and then watch the video. All right, so on the first one here, the conjugate is 3 square roots of 2 plus the square root of 5. That's what you're going to multiply by in the numerator and denominator. So we have 6 square roots of 3 times 3 square roots of 2 plus 5 over 3 square roots of 2 minus 5 times 3 square roots of 2 plus 5. So here's where things are going to get a little more complicated. You might even do this multiplication off to the side. Notice here, this is 4 numbers multiplied. I'm going to multiply the 3 and the 6, that's 18. I can multiply the radicals. Square root of 3 times square root of 2 is square root of 6. And so that's 18 square roots of 6. And then when I multiply 6 square roots of 3 times 5, notice I can only multiply the 6 and the 5 together. You get 30. And the square root of 3 I can't do anything with. So it'll be plus 30 times the square root of 3. In the denominator, 3 times the square root of 2 times 3 times the square root of 2. We know 3 times 3 is 9, and square root of 2 times square root of 2 is 2. It's all multiplication here, so we're going to get 18. And then a minus 5 times a plus 5 is minus 25. So this is 18 square roots of 6 plus 30 square roots of 3 over negative 7. Now, I think that you'll be able to put your answer in like this, but you may have to put that negative out front. We've discussed in the past how if you had like negative 3/4, that's the same as negative 3 over 4 or 3 over negative 4. So a negative in the denominator, we don't tend to leave it there. You'd probably want to move it out front, but I think you may be able to get away with putting a negative 7 on that problem. Okay, let's move on to number 9. The conjugate is the square root of 3 minus the square root of 5. Notice it's always the denominator that we're trying to deal with, because remember, it's rationalize the denominator. So that's what drives what we choose. So we choose the conjugate of the denominator here. So the numerator will get multiplied by the same thing. So now we've got a little more work to do because we're multiplying binomials in the numerator and denominator. So we have 2 plus the square root of 3 times the square root of 3 minus the square root of 5 over the square root of 3 plus the square root of 5 times the square root of 3 minus the square root of 5. All right, so here we have 2 times the square root of 3. I can't do anything but put those together. And then 2 times a minus square root of 5, that'll be minus 2 square roots of 5. Square root of 3 times square root of 3, my inner product, that's just 3. And my last product, square root of 3 times a minus square root of 5, is minus square root of 15. I want you to notice that none of those are like terms. These are not like radicals, and neither is that one, and then this is not even a radical. So our denominator won't simplify in any way. Here, square root of 3 times square root of 3 is 3. Square root of 5 times a minus square root of 5, we're going to get them negative, and of course square root of 5 times square root of 5 is 5. And so finally, we get 2 square roots of 3 minus 2 square roots of 5 plus 3 minus square root of 15 over negative 2. Again, I think in this case they would probably apply the negative to the numerator. The other way you could write this is basically negative 2 square roots of 3 plus 2 square roots of 5 minus 3 plus square roots of 15 over 2. So basically, I just moved the negative to the numerator and I had to apply it to each term in the numerator. Again, I think you could probably give this answer here, but that is possible. It's possible they may want you to do this. All right. Number 10, we should be multiplying by 6 plus the square root of x in the denominator, so we'll do the same to the numerator. So here we have 3 plus the square root of x times 6 plus the square root of x in the numerator. And the denominator, we have 6 minus the square root of x times 6 plus the square root of x. So, let's just do this to kind of separate that. So here we've got 18 plus 3 square roots of x. The inner product is 6 square roots of x, and the last product, square root of x times square root of x, is x. In the denominator, we have 6 times 6, which is 36, and a minus square root of x times a plus square root of x, that's minus x. So to finish this, we need to combine our like terms. Notice 3 square roots of x and 6 square roots of x, that's going to be 9 square roots of x. Don't forget that x at the end. And then in the denominator we have 36 minus x. And that's all we can do there. Notice this is a radical term, this is an x term, this is a constant. None of those are like terms. Same thing in the denominator. All right, we're down to our last one here. So here you should be multiplying by the square root of a minus the square root of b in the denominator and in the numerator. So we have the square root of a minus the square root of b times itself. And in the denominator, we have our conjugates. So when you do the four products here, square root of a times square root of a is a. The outer product is the square root of a times minus the square root of b. We'll get minus the square root of ab. And the inner product is also minus the square root of ab, because you have square root of a times square root of b. Remember, you can multiply the numbers that are inside since they're both square roots. And then finally, you have a negative square root of b times a negative square root of b. That'll be plus just b. In the denominator, square root of a times square root of a is a. Square root of b times minus square root of b is minus b. And the only thing that we can do is notice these are like radicals. They both have ab underneath the radical. So we have a minus 2 square roots of ab plus b over a minus b. All right, that's going to be it for this video.